Hello, good morning, my dear students. Yesterday, or in the last lecture, we were discussing about index number. Why we need an index number? What is basically an index number is all about? And what are the different types of index number and how index numbers are being constructed? So these are all the portions that we discussed in the last classes. Okay. So today we will discuss some of the weighted index number measures or how to construct weighted index number. So as I told you before, broadly there are two types of we can construct an index number either using weighted index number or unweighted index number. In unweighted index number, we will treat all the commodities are of equal importance without considering its relative importance in a commodity basket. Okay, but many of the times the relative importance of a commodity in the commodity basket is very important. We cannot always treat all the commodities in a commodity basket as the same. For example, uh, certain commodities we rarely buy, but its cost will be very high. For example, uh, gold ornaments, we rarely buy it, okay? But if you buy a 1 uh, or 8 gram gold, which is equal to 1 sovereign, okay? And now its rate is about 36,000 something, or you treat it as a 30,000, okay? Where the rice is a very important and most essential commodity in our commodity basket. We usually buy 10 kg rice per month. So in a year, we usually buy more than 1 kg rice. Okay, but 1 kilogram rice is around 30 rupees. 1 kg rice is 30 rupees. 1 gram gold is around 30 or 4,000 rupees. Okay, or 1 kindle rice is about 5,000 rupees, or 8 gram gold is around uh, 40,000 rupees. Okay, so without we are not if you are not considering the weights, okay, and if you are considering an index number only based on price, the gold will have more weight, or that means the purchase of the gold will impact our index number. Okay, but we have bought a very 8 gram gold. Okay, so 8 gram gold will be more weighted in your index number because its price is very high. Okay, so this is the problem with unweighted index number. So we have to consider the weight or the relative importance. Okay, so when all commodities are not of equal importance, we have to assign weight to each commodity relative to its importance. Okay, and an index number which is calculated from this weight or considering the weight is known as weighted index number. Okay, so an index number which is constructed by considering the weights or the relative importance, it is known as a weighted index number. Okay, so What will be the weight? That's a very crucial question. Price cannot be a weight. Okay, so there are two different types of weights. The one is the quantity of purchase is a weight. Okay, so if you are purchasing more rice than gold, then the weights of this, the weight of the purchase or the quantity of the purchase will become as a, or will consider as a weight. Okay, or the second item is the value. The value means price into quantity. Okay, so there are two different types of weights, or we can use either the quantity as a weight or the value as the weight. Okay, okay. So if you are considering the weight, and still we can construct an index number using two different methods. The first method is weighted aggregate method, and second one is the weighted average of price relative method. Okay, so there are two types of weighted index number. The first one is the weighted aggregate price method index method, and the second one is the weighted average of price relative method. Okay, yes. Yes. Now, under the weighted aggregate index method, we are giving appropriate weights to various commodities to reflect their relative importance in the group. Okay, so usually what we do is for an index number is constructed in such a way that the weight multiplied by the prices in the current period divided by sum of the weights multiplied by the, or the weight multiplied by the current period price divided by the weight multiplied by the prices in the base period. Okay, and we are taking the aggregates of these two things. So the price index number for the current period based on base period will be equal to sigma WPR P1 divided by sigma WP0 into 100. Okay, yes, but the problem here, what will be the weight? The weight can be quantity or weight can be value. But if you take, suppose if you are taking the quantity as the weight, which quantity will take as a weight? Whether you will take the quantity of purchase made in the base period or quantity of purchase made by in the current period. So which one you will take as a weight? Okay. So regarding this, among different statisticians, there are certain debates. Different statisticians have used different methods of assigning weights. Okay, so there are different popular weighted index numbers such as last pair index number, past stay index number, Darbish and Bowley's index number, Fischer ideal index number, Marshall Edgeworth index number, Walsh method of Walsh index number, and Kelly's index number. Okay, so there are 7 most popular weighted index number. And why we are having different weighted index number? Because all these different statisticians have used different method to assign weights. Okay, yes. So we will discuss each method by one. First method is last pairs method. Last pair, uh, he was a statistician and he has constructed this index number in 1817. Okay, so last pair price index number is a weighted index number. Okay, weighted aggregate price index number where weights are determined by quantities in the base period. Okay, so here what we are doing, we are considering the weights, okay, the weights as the quantity that we purchased in the base period. So Q0 will be the weight. Q0 will be the weight. Okay, so the most important feature of last pair method is last pair considered the Q0 as the weight. Okay, so what will be the index number? According to last pair, uh, the price index number for the current period considering 0 as the weight, that is called P01. P01 means P price index number for the period current year based on base year. Okay, so is equal to sigma P1Q0 divided by sigma P0Q0 into 100, where this Q0 is the weight. Okay, so the peculiar feature of the last pair method is he assigned Q0 as the weight. That's all. Okay, yes. Now, the second method is the past chase method. The only difference between last pair and past chase is past chase considered the quantities in the current period as the weight. He considered Q1 as the weight. Okay, he said that the weight should be the quantities purchased in the current period, not in the base period. Okay, so Pasteur was a German statistician and he has devised this method in 1874. So this method will be, as per this method, the price index number for a period is equal to sigma P1, okay, divided by sigma P0. Both are multiplied by the weights, and weight is not Q0, here it is Q1. Q0, not Q0, but this is, look at this, Q1. Q1 is the weight into 100. Okay, so what is the difference between last pair and past chase method? In last pair, he considered Q0 as the weight, where in past chase method, he considered Q1 as the weight. Okay, yes. Now, the third method is the Dorbish and Bowlis method. Dorbish and Bowlis are two different statisticians. Okay, what they have done is they combine this last pair and past pair method. Okay, what they have done is they have added these both methods. So instead, they have not taken Q0 or Q1 as the weight. Okay, instead they have taken a combination of this last pair and past chase method, or the last pair method is basically assign the weight or assign Q0 as the weight. Past chase method, he assigned Q1 as the weight. So what Dormish and Ball is doing is they have taken a combination of both last pair and past chase. Okay, so how they have combined this last pair and past chase method? Using the arithmetic averages. Okay, so they added last pair method to past chase method and divided by 2. What is this 2? 2 is the number of observations. Okay, so the first observation is what? This is the first observation. Okay, sigma P1 Q0 divided by sigma P0 Q0. This is nothing but last pair method plus this is what sigma P1 Q1 divided by sigma P0 Q1. fastest method, then divided by 2. 2 is what? This is 1, this is 2 into 100. Okay, so Dormish and Bowley, they have combined this last pair and fastest method using arithmetic average. So he has taken the arithmetic average of last pair and the fastest method. Okay, now the fourth one. Okay, so the fourth one method was developed by Irving Fisher. He was a economist, statistician, and econometrician. Okay, so what he has done is he also combined this last pair and fastest method. Okay, but Dorbish and Bowley, he has taken the arithmetic mean. Okay, and as you know that for an index number, the best average will be the geometric mean, not the arithmetic mean. Okay, so in your last semester classes, we have learned that if you want to find out the average of indexes, growth rates, okay, then arithmetic mean is not a right choice. We have to use geometric mean. Okay, so what this Fisher has done is he has combined last pair and fastest method using the geometric mean. Okay, so he used both base year as well as current year quantities as the weight. Okay, so Dorbish and Bowley and Fisher both have considered Q0 and Q1 as the weight. But the difference is Dorbish and Bowley has taken the arithmetic mean, whereas this Irwin and Fisher they have taken, or he has taken, the geometric mean. Okay, so you look at the equations. This is the last pair method. This is the past tense method. Okay, if you taken the root and the product root, it is nothing but the geometric mean. Nth root of the product of an observation, it is nothing but geometric mean. Okay, so he as per this Irving Fisher weighted index number is the geometric average of the last pair and the past tense method. Okay, yes. Now, if you consider all these index number, then Fisher index number is the most popular and most acceptable. Okay, or it is usually said that it is most ideal index number, the most ideal index number. Okay, so why it is considered as the most ideal index number? Because of the four reasons. Okay, the first reason is it is based on weights. The first one is it is based on weights. Okay, and what weights? It is considered the quantities in the current period as well as quantities in the base period as the weight. Okay, and it is based on geometric mean, which is considered as the best average for calculating the average of index number. And the last one is it satisfies both time reversal test and factor reversal test. Okay, so there are there are many tests to check the adequacy of an index number. Okay, and the most important test are the time reversal test and the factor reversal test. Okay, so this Fisher index number is the only one index number that satisfy both time reversal as well as factor reversal test. Okay, so because of these three reasons, first reasons, it consider Q0 and Q1 as the weight. Second, it is based on geometric average, and third one, it is satisfy both time reversal and factor reversal test. And due to these factors, it is considered the Fischer index number as an ideal or most popular and most acceptable index number. Now, the next method is the Marshall and Edgeworth index number. Marshall Edgeworth index number. Okay, so Marshall and Edgeworth, these two person is also economist. Okay, they used the arithmetic gross of quantities in the base year and current year as the weight. Okay, so they have taken the arithmetic mean of Q1 and Q2 as the weight. Okay, that means weight is equal to Q0 plus Q1 divided by 2. Okay, so according to them, the price index number for a period is equal to sigma P1 into weight. Weight is Q0 plus Q1 divided by 2 whole divided by sigma P0 into weight. Weight is Q0 plus Q1 divided by 2 into 100. Okay, so in numerator and denominator 2 is there, so 2 can be cancelled out. Okay, now it is sigma P1 Q0 plus Q1 divided by sigma P0 Q0 plus Q1 into 100. So it will be sigma P1 Q0 plus sigma P1 Q1 divided by sigma P0 Q0 plus sigma P0 Q1 into 100. Okay, so this will be the equation for Marshall Edgeworth index number. Sigma P1 Q0 plus sigma P1 Q1 divided by sigma P0 Q0 plus sigma P0 Q1 into 100. Okay, so the peculiar feature of Marshall Edgeworth index number is they considered, okay, what they have considered? They have considered the arithmetic mean of Q0 and Q1 as the weight. Okay, yes. Now Walsh method. Under Walsh method, Marshall Edgeworth, they have considered arithmetic mean of Q0 Q1 as the weight, but Walsh considered the geometric mean of Q0 and Q1 as the weight. Okay, so instead of taking the arithmetic mean of the base year and current year, Walsh has taken the geometric mean of the base year and current year quantities as the weight. Okay, so the Walsh method, weight is equal to root of Q0 into Q1. Okay, so price index number is equal to sigma P1 into weight. Weight is equal to Q0 into Q1 under root divided by sigma P0 into Q0 Q1 into 100. Okay, yes. Now the last method is the Kelly's method. Okay, so Truman L. Kelly, he developed a method, and this method is known as Kelly's index number. Okay, and this index number is also called the fixed weight index number. Okay, because the weights to be under this method, the weights to be fixed for all period, where the weights are the quantities which may be referred to some period, not necessarily the base or current period. Okay, so under this method, the average quantities of consumed in both current year and base year or more than 2 period may be used as the weight. Okay. So under this method also, uh, quantities purchased. Okay, quantity purchased in the uh, different period, not necessarily two period. Okay, so in all this method, we have told that the quantity purchased either base period or current period will be the base. Okay, but Kelly said that we can take the arithmetic mean or geometric mean of quantities purchased both in current as well as base period. Okay, and we can also take the quantities purchased more than two period. Okay, so suppose there are 5 years, you can take all these 5 years quantities. Okay, and you can compare the price between two period. Okay, for example, 2015, 16, 17, 18, 19, 20 data is there. Okay, and if you want to if you want to compare the price changes between 2015 and 2020, okay, you can consider all the quantities purchased in all the period. Okay, and you can take their arithmetic mean or geometric mean as the weight. Okay, so he defined uh, P01 is equal to sigma P1Q divided by sigma P0Q into 100, where Q is the weight. It can be the arithmetic mean of the weights, mean of the quantities, or geometric mean of the quantities, and quantities can be two period quantities, three period quantities, or more than two period quantities. More than two period, it can be 3, 4, 5, 6, or as many as. Okay, so this is the uh, Kelly's method. Okay, yes. So on the next day, we will discuss or we will do a problem and on how we can do all these, how we can find out all these index number using certain numerical examples. Okay, then after that we can compare the sum of the index numbers. Okay, so let me to repeat certain things that we have discussed so far. First thing is why we need weighted index number. Answer is, in order to capture the relative importance of commodity, we need to consider the weights. Okay, so in a commodity basket, all the products is not having the equal importance. Some commodity may have more importance in our commodity basket, so we have to consider the weights. Okay, so by considering the weight, the most crucial question is what should be the weight or what should be the ideal weights. Okay, so the main answer is, or the main choice is, the first one, the weight should be the quantity purchased or the value of the purchase. Okay, quantities or values. Okay, so by considering this as weight, we can have two different weighted index number. First one is weighted aggregate price index number and weighted aggregate price relative index number. Okay, so in weighted aggregate price index number, the equation is sigma P1 into W divided by sigma P0 into W. Okay, so regarding this W, there is a debate among different statisticians, and different statisticians considered different quantities as the weight. Okay, last pair he considered he considered Q0 as the weight, where Pasteur considered Q1 as the weight. Okay, then Dorbish and Bowley considered the arithmetic mean of Q0 and Q1 as the weight. Okay, whereas uh, uh, the Dorbish and Bowley considered the arithmetic mean of last pair and Pasteur's method as the weight, as the index number. Then in Fischer index number, they have considered the geometric mean of uh, the last parent pastures method. Okay, then Marshall and Edgeworth, they have considered arithmetic average of quantities purchased in the base period and current period as the weight. So as a contrary of this, Walsh considered geometric average of the Q0 and Q1 as the weight. Okay, and last one is Kelly. Kelly considered the arithmetic average or geometric average of quantities purchased in the not only in the base period or current period, but many periods. Okay, so it is a fixed weight index number. Okay, so these are all the different index number that we have discussed today, and tomorrow we will come with a problems and how we can calculate index number using all these three different methods. Okay, thank you.